Hi everyone, this video is going to show you how to populate the 5-volt power supply kit. Now this is a pretty straightforward kit. The surface mount parts are pretty large comparatively. We've got parts on both sides of the board, so we want to be careful that we populate parts that don't make this too challenging down the road. So if we start with the big huge parts, once we start doing this side of the board, it's going to be rocking all over the place. So we don't want to avoid that. So what we're going to do, we're going to populate these 5 resistors and this fuse first, because they're all the same height and they're pretty flat. Then we're going to come over to this side and populate the lower, kind of the smaller parts here, and then we can do the rest of the larger parts however we want after that. So let's get started with these parts here. So R5 and R6, R7 and R8 are what we're going to do. Same with R4 and F1. So the way that I like to do parts when I'm populating a board is I always blob up my solder on one of the terminals on all the parts that I'm going to work with. And this just helps me do kind of one thing at a time. It's kind of like an assembly process. So right now my brain says we're doing solder blobs on one part of each of these components that we want to do. Okay, so no harm in that. So there we go, we're all ready there. So looking at the bill of materials, we can see that parts 5 and 6, R5 and R6, they live in compartment 3A. So we'll go to our kit, grab our tape of parts. And if you want, you can verify them. These are nice and easy to read. They should say 1003, which means they're 100K resistors. So we'll plunk those down. And don't ever open up more than one kind of part at a time, because you're just begging to get them mixed up. So let's come in and solder these 2 parts, R5, R6. Resistors, they don't really matter which way they go. It's nice to have the label facing up so you can actually read that those parts are, what the values are, and they aren't polarized either. So make sure you get these in the right spots, R5 and R6. If you want to look at detailed steps on how to do surface mount soldering, you can check out some of the other videos online. I don't want to bore you guys if you've already checked that out. So the other side on these 2 parts. And there we go, there's our first 2 parts. Okay, let's do R7, R8. So check our bill of materials. That compartment lives in, or those component lives in compartment 5A. These guys are stamped with 6802, which says to me there's 68 Ks. And you can confirm that on the bill of materials if you want. Let's try and get those up the same way. Drop them on, heat up, slide in. Remember, with the bigger parts, you're going to take a wee bit longer for the solder to solidify every time. So don't be too hasty in pulling off your soldering iron and your tweezers. Give it a few seconds there before you let go of the tweezers, or else you're just going to drag the part off the board, which would be no fun. And do the other side. Be nice and patient. With 1206 parts, they are really huge, so you can easily watch the solder flow. Be nice and patient. And usually you don't even have to go back and touch up anything with these guys because they're just so nice and big and easy to work with. But if you want, you can always go do that. Make sure you're always clipping or wiping your tip off to make sure we're good. Okay, R4, we'll do that next. So R4 is one of the parts in compartment 4A. So let's grab one of those. You say 3601, which are 3.6K resistors. Put the other part back in the right compartment because we don't need that yet. It's on the other side of the board. It's the handy little trick for flipping parts over. You just tap the paper that you're working on. And if it's not too flat, it'll flip over. Let's get in there for this guy. There we are for R4. And the last one that we'll do is the fuse. which is in compartment 6A. Again, the fuse is not polarized. We can put it any way we want. We'll flip it this way. We seem to be putting all of our text facing this way. Here, it's a big pad, so go in sideways kind of with your iron. It'll heat that up no problem. Slide her on there. Let it go. If you want, just make sure it's flat. You can hold your tweezers on there. Just touch that side again. And that'll make sure it's right flat on the board. And it was. If it wasn't, they tend to make this little clicking sound as soon as the solder melts just enough to get in there. So it's a nice way to know that, oh yeah, I just seated my part a bit better onto the board. Come on this side, so I'm nice and patient. Give it lots of time to flow in there. Lots of solder. And there we go. There's our fuse. So this is coming along quite nicely. Okay. We're not going to do this diode because it's a bit tall. And like I said, with just these parts populated, I can flip this over now, and this doesn't rock back and forth. It's still pretty solid. It's going to move a bit, but that's kind of the best that we can expect with doing a double-sided board. So now we can kind of pick parts at random. We still want to go with these smaller parts here. Let's start with the IC, the integrated circuit, just because it's probably the most complicated part on here. And since it's the most complicated, it's nicer when we don't have anything in the way. So this guy is the component in compartment 3C. Oop, drop that down. For this guy, really, really important that you find the pin 1 location correctly. So on this part on the board, there's a little crescent moon here, and you need to find a similar mark or something that indicates that the top part of the part on this part. And in this case, it's a kind of a white bar or a stamped bar on there. So make sure that that's up. If you do get this backwards, you can get them off, but we don't want to do that. It takes kind of a long time. Okay? So get the part in position, and actually I'm using my iron to hold down the board there. I can use my iron to hold down the board here to get this in position, and then I can bring my iron in. I'm still kind of using it to hold the board in place, and I just kind of almost roll it in to get the solder to melt, and then just slide this guy in like so. So with the iron in place, be looking on the top, gently just turn the part and adjust it so that you get it all lined up on the pins. When you think it's correct, move your iron away like this, give it a few seconds, and then take your tweezers away. It doesn't hurt to do a quick inspection with your magnifying glass or whatever you're using as an inspection tool. So check it for alignment, and also check it to make sure that it's still flat on the board. And again, if it's not flat, you can put your tweezers on like so and heat up that one part again, that one pin, okay, and it will snap down if it was not flat before. Okay. Also at this time, if you want to adjust it, grab the part, then come in with your soldering iron, do your adjustments, and then iron away, tweezers away, and re-inspect. Okay. Assuming everything is correct here, let's go and pick the pin opposite to this one that you already soldered, and come in here and just turn the board on a bit of an angle, and come in on the pad, and just dab the solder and make sure you see it go onto the pad and up the part. It's even easier to touch right onto the pin. So we can try that. If you bridge to the other parts, or the other pins right now, don't worry about it, we'll fix that later. Okay. Some components will actually solder that are so fine pitch that you end up bridging almost all the pins, but it's pretty easy to fix after. But this component is actually fairly large, and you should be able to access each pin individually like this. Okay. You notice that I always turn the board around to best meet what I need as far as position goes. So my right hand is my most useful hand, so the most delicate work always stays on my right hand. So I make sure that I turn the board to put that in the right spot. Okay. So as a demonstration, I bridged that last little pin. Okay, so you can see these two pads are actually bridged. Let's see if we can bring that up to the camera. There's no way we can bring that up to camera. But hopefully you can see that bridge. So all I'm going to do is get a nice clean tip on my iron, and I can probably just touch this a few times and pull this right off. And maybe I'll go right in between the pads there. Give it a little bit of heat. And if that doesn't work, which it's not right now, that's okay too. You can take a bit of solder wick and just touch this down with the iron onto the pads, like so. And you'll see the solder pull off a bit. And there's some pretty good videos about solder wicking also online. And that's just something that you have to practice. You just have to be careful that you don't rip pins off or pads off with solder wick. Okay, so I'm just going to inspect this myself here, make sure we're good, and all looks fine. Okay, so let's get ready to do these other parts. Might as well just do all of our solder blobs for the one side of the component that we want to solder, whichever one it may be. I always pick the same side, so on these three parts I'm picking the left side, and then I won't have to turn the board. Same with this, I'll just keep it, assuming that I'm going to come in from the right. So those are the remaining kind of small parts on the board, and we can do those in whatever order, so we'll just start going through. Let's start with C6 there. So from the bill of materials, C6, using compartment 1B. So capacitors have kind of a brown or beige color, unlike the resistors that of course are black, as you saw. So you can peel that guy out. These are ceramic capacitors, and ceramic capacitors are not polarized, so we don't have to worry about which way we put this in. And capacitors are never labeled. At least I've never seen one labeled. So we don't have to worry about any positioning or right side up for labels or anything like that. Solder's exactly the same way. Sometimes your board sticks to your finger. That's alright. Come in and do that guy. Okay, so let's do C5. So C5 is a slightly more challenging component because it's an 0805. All these other parts are 1206. When I built this kit, I said, let's put in one smaller part just to make this a bit more fun. We could go even smaller, but we won't do that to you on this kit. However, if you want a sales pitch, Ingenuix certainly does have a lot of kits all the way down to parts that are 0402. So less than half this 0805 size. And that's typically what industry uses, is 0402 and 0603 size parts, just so we can make devices nice and tiny. And it does make a big difference in what you can populate. So there's that guy. Let's do this diode D1 now. D1 is in compartment 2C. Diodes are polarized, so you have to make sure that you get this in the right way. They tend to sit on their back, so you got to flip them around. And here you'll have to look very closely when you are working with your part. But again, you can just turn the part and look closely to find the what we call the cathode mark. So it marks the negative side of the diode. In this part, it's a very thin line. So make sure you can see that. In this case, the line is on this side, on the right side, as I can see it here. And there's two little marks on the board that indicate where that line should go. So there's always a cathode mark on the part, and there's always a cathode mark on the board of some sort. Different vendors will have different ways to mark their parts. So we sort of just say in general, look for some sort of mark and line up your marks, rather than saying look at lines or look at whatever. So you put that guy on there. Same process. You might just want to double check that you didn't flip it around. Check that that line is still in the right spot. It's kind of like in carpentry, how you measure twice and cut once. Well, inspect twice and solder once. There we go. Just go and touch up that other side a bit. Make sure you got a good connection. We'll do C2 next, and that's in compartment 3B. So he's another big capacitor. So if we had taken this capacitor out at the same time that we took the other capacitor out, we might have been a little bit stuck because they are identical looking, even though they're substantially different values. And with capacitors, you might have a substantial change in the way that the circuit works if you have the wrong value, but also in some cases you might not even notice. In this case, you would notice. Well, maybe you wouldn't notice. Oh yes, you would notice, as I think about how the circuit works, because this little capacitor is a very high frequency capacitor. It's only 470 picofarads, and it's doing some filtering that if you had the other one on, that's a much larger one, you wouldn't get the filtering action. You'd actually probably slow down the switching power supply, so it wouldn't even work. Let's do R2 and R3 next. R2 is the remaining component in 4A. Grab that out. And if you squeeze your tweezers too far back, that actually opens them back up, just the way that the material flexes. Makes it hard to grab tapes. So R2 on its way in. It's fairly irritating to drop parts, but happens. Get that guy going in there. Good. For R3, it lives in compartment 2A. That really is quicker than trying to flip it, trust me. There we go. And last one is R1. Lives in compartment 1A. You might wonder why they don't just put the parts upside down in the tape, so that when we tip them out, they're the right way. Well, that's because usually machines are the ones that are pulling them out. And they just use vacuum nozzles. They suck the part up and drop it down. So we don't want it upside down. There we go. Okay. So now we've got the main kind of small parts done. There are 3 big capacitors and a big inductor on this side. And we've got the LED and the switch on this side. So you can see the board's starting to rock a bit now, since some of these parts are slightly off, not all the same height. So we can it doesn't really matter what we start populating at this point. I think that it's probably best to do all these parts on this side, because we still have the most stability here. So let's do that. Let's do all these big capacitors. So we're going to pick on these, let's do these 3 big guys here. So again, we're going to put our blob of solder on. And I very specifically picked this side of these 2 caps because we want to be able to slide it in. We don't want these components in the way here. This one doesn't matter so much, although it's probably easier. Doesn't really matter. It might be slightly easier to do this one. So we'll just start with that. These are not all the same value, so be careful here. Two of them are the same value, but one is different. So C4 and C3, these two guys, they're both the same value, and they're in compartment 5B. These are big caps physically because they're big capacitances electrically. These are electrolytic caps, which is a different kind than ceramic, and electrolytic caps are polarized. So you can see on the part here there's a black strip, and you want to make sure that that is on the negative side. So again, for electrolytic caps, they mark the cathode, which is the negative side, and you have to figure out how the board is marked. In this case, the board is actually marked with the outline of the package. So these little chamfers up here match the chamfers on here. So even though the cathode is marked on this part, we're using the physical appearance of the part to actually locate it. So let's put these in the right spot. So these are the big ones. So we're going to come over here. Let's do the middle one first. So there's lots of heat involved in this because these are big parts. So make sure that we're all ready here. I'm going to go in with a pretty broad part of the iron here. You could use your fingers to do this, except the part will heat up, so you got to be careful. So I'm going to stick with the tweezers because I try not to burn myself very much. I don't like it. So here we're going to very slowly slide this in, make sure that we stay melted. And you just keep sliding with that iron in place. Sometimes you kind of have to wiggle it because it'll get stuck. Until it's approximately right in the center, and until you can see lots of the pad and the pin on the other side. So right down here, there's lots of pad visible there. Okay. Let's just slide this other one in. It's going to be pretty tight to get it past there, but not too bad. Okay. As long as you have a good pair of tweezers, you're going to be okay. So we'll slide that in. They're also hard to grip just because they're big round parts. You can see it actually is fairly straightforward to get it on there. And the board's tipping a bit, so this part's probably going to end up a bit crooked. But that's okay, because we can come in after the fact and just press it down again. Make sure it straightens out. And if it does end up a bit crooked, other than people that might say, hey, your capacitor's crooked, electrically, it's not going to make any difference. However, aesthetics sometimes does play a major role in electronics. So we like to make things as neat as possible. So you can fix crooked parts if you want, though if they're electrically functioning, then you don't actually have to. Okay, so there's those two big caps. The other one here is in compartment 4B. Same situation, it's located by the physical package. Nice and patient, make sure your solder is melting all the way. Slide it in. Like so, and release. Give it a few seconds because again it's lots of solder on there, lots of heat, so it'll take a while to solidify. And there we go. To our other side. And those big caps are done. Okay, let's do the inductor next. Again, let's pick the side that is going to allow us to slide the part in without getting in the way or without the other parts getting in the way. So lots of huge big solder blob on there. This is part L1, which is in compartment 6B. So on this part, make sure that you notice where the pads are. Some of these parts, depending on they are, some of them have a square base, some of them have this round base here, but you want to make sure that you put the pads this way If you put them on this way, that obviously isn't going to work because it's going to short across those two pads. So you want to make sure that when we put it on, it's this way. So these two little dots, they identify the pads. Not really dots, I guess they're kind of cutouts. Inductor does not matter which way it goes. Sometimes it does matter which way inductors go. So depending on the circuit, make sure you understand the requirements of polarizing inductors or not. Usually it matters only if there's more than one inductor. Okay. So go with the big broad side of the iron. Get this on here. These pads are nice and big. It's nice and easy to work with. Spend lots of time. You can sort of push and poke this in. Once you think you've got good flow, touch your tweezers to the top to hold the part down. Bring your iron away and watch the solder. Okay, it's going to take a few seconds, if not 10 seconds. Right there is when it finally finished solidifying. So there's a lot of heat captured in this circuit when we do it, so you have to spend a lot of time. You can, like I said, you can see the solder kind of change color as it re-solidifies. Like with any other part, just double check that it's all in place properly. So you can use your magnifier to make sure that it has soldered, and inspect that your other pad is, or the part is flat on the other pad. And then again, come in, nice clean tip on the kind of the broad side here. And again, it's going to take a while to heat up here. We can start dabbing some solder in. And we're going to just keep this on here, and we're going to keep dabbing solder on here. We're going to go all the way over to this side and make sure that we can melt solder over on this side, even though the iron's on the other side. And we're going to keep this on there a bit longer until this is a nice smooth lump of solder. And then we can take our iron away, and we know that the part has flowed under there. And again, watch how long this is still not solidified. It's coming right there, and I hope you can see that on the camera. But it looks very, very shiny when it's not solidified, and it'll go slightly cloudy as it solders, or it solidifies. Is the word I'm looking for. All right. So that's the inductor. This is hot right now. Don't touch that because it'll keep a lot of heat. Remember, this is coming up to about 600 degrees. So this side of the board is done. Now we can flip back over and check out what we have left to do here. Okay. So we've got two parts left on this side. We've got the diode and we've got the switch. Okay. We do have to start managing this problem now. So we're rocking back and forth with this board. So it's not too bad. You can do different things. You could tape this down, you could stick this in a little holder, or you could just deal with it. You kind of know what to expect. So you can use your fingers and use the iron and just work with it. Make sure that it's not going to slide around on you. And I think we'll be okay. So this diode, it's an LED, it's in compartment 1C. Be careful with this one. This one is polarized as well. So make sure on this part, you can see one corner has a little chamfer on it, just a little bit of a slice through the top plastic. That's got to match up with the chamfer mark on the part here. Okay. So with that in the right spot, because LEDs are just like normal diodes, so they have cathode marks, and that's all this is. So slide this guy in. With this part, you can melt the plastic pretty easily with the iron, so you want to make sure you don't touch any of the plastic part with your soldering iron. Come and solder this other part. Here I'm not touching the plastic, I'm just touching up against the pad, dabbing my solder in. Okay. And our last part is the switch. So this is a 6-pin part. Only 3 of the pins are actually doing anything, but we'll solder all 6. It's sitting in compartment 4C. It doesn't matter which way it goes. Since the Ingenuix logo and all the text is the right way up here, then you might want to orientate the text the same way, which would be at the bottom in this case. This will be a bit tricky because of the rocking of the board, but we should be able to do it, and we can sort of get it in place temporarily, like so. And if you have someone else here, get them to hold the board here. If you don't have someone here, take your soldering iron, get it or your base of your soldering iron and get it to hold the board for you. That's what engineering is all about, improvising and making things work with what you've got. What you want to be really careful of is that you don't heat up here and burn your LED that's right next door. So there we go, I got that part on with the help of my soldering iron base. Thanks, soldering iron base. And then the other parts will be fairly straightforward. So the same thing like that big IC, just kind of touch on the pad and the part. Takes a while to heat up because it's big. Make sure you have good flow. Here I can hold the board, put my iron down, oops, and flip the board. A little too much pressure. So just adjust that pressure a bit. Solder that one. These are the little things about soldering that you just have to work with. You can also do other things. There are little tools like helping hands that can help you do this sort of stuff. But if you're doing stuff as an engineer, you often just sometimes need to get stuff done here and not mess around with all these other tools, or sometimes they're too expensive to buy. So you just find out ways to make that work. Okay? So that's all of the surface mount parts on this entire device. Okay? Pretty good. So all we have left are a few through-hole parts, and there are none on this side. They will come through. All of the through-hole parts are on this side. So the USB connector and we have the two battery terminals. So these guys are the worst to do. Let's do the USB connector first. It's in compartment 3D. You pretty much can't mix this one up. You do need to snap it into place, so it does have some holders that go through on the side. So you need to pick your board up and then just gently press this in, and it should lock into place like that. Okay, it should be nice and flat at the base there, and all the pins are visible coming through there. So here we can start, might as well start with the big components on, or the big pins on the side. It's nice on this side because I can hold the board down with my finger while I'm soldering these parts. You can dab a whole bunch of solder on there. Be nice and patient, watch it flow around onto the pads. You don't have to fill up these holes. You can if you want, but as long as there's some solder on there providing some mechanical strength, that's all you really need. This one's easier to do in the center because the board's not rocking. So dab some solder on. Sometimes you need to adjust just a bit so that you can get some heat and solder both on the pad and the part. There we go. But eventually it does in fact work. And then we can go and do these individual pieces. And there we go. There's our USB connector. And that leaves us with these last two battery connectors. So with these guys, there are two really important things to watch out for. One, we want to make sure that we don't get these in the wrong spot. Okay? These things are impossible to get off if you get them in the wrong spot. Your USB connector will still be hot. I just burned my finger. Be careful with that. This is the positive terminal. It's got a little indent here, which is supposed to be reflective of the fact that this is an indent here, so it's the female side, whereas this has a slightly thicker line right there indicating it's the male side. Okay? And on your bill of materials as well, it says in these components and the compartments which one is the positive side and which one is the negative side. Okay? So don't get these in the wrong order. Okay? your USB connector is still probably hot, so be careful. So these guys slide into place. Okay, do these one at a time. It's really important to push these down nice and flat. Okay, so they should sit by themselves without moving, which really helps. Okay, if they are free to move, then it's really difficult to get them straight. And if they aren't straight, when you try and plug your battery in there, it's not going to be aligned properly. So make sure you push them in as solidly as possible. There's a very wee bit of space all around it that still sticks up, but generally they are as flat as possible on the board. And if you look this way, they're at a perfectly 90-degree angle to the board. Okay? So make sure that's done. Double check that you've got the negative terminal on that side. You can gently rest this on here. You don't press on this because you might tilt the connector. And come over and get one of these terminals soldered down. So let's just do this top terminal because it's the easiest to access. The second thing you need to remember is that this is one huge solid part of metal, and that means that everything on it is going to be super hot. Okay? Don't burn your fingers. Once you've got one side tacked in like that, double check it. So come back to this side, make sure you're still at a perfect right angle, and as soon as you have one on there, you're pretty safe, so you can come in and do the remainder of those 3 terminals. But remember, this is going to be hot for a long time. So you can go and have a celebratory beer if you're old enough to have a beer. If not, have a celebratory Coke. That one's done. Very carefully, without burning your fingers, you can put the other one in. If you're worried about burning your fingers, give it a while, a few minutes to cool down. Okay, again, push this in nice and tight. Okay, these should be perfectly square. Again, right angle to the board, and they should sit nice and tightly in there. Same thing, do this top part. Like so. Make sure this covers completely on the pad. Double check it. Okay, we're nice right angle. Look from the front, it's straight. So now you can do the remaining pads. Lots of patience, lots of heat, and lots of solder. You should get nice connections. And that, my friends, is it. There's your 5-volt USB power supply. It's in the off position. Now all that's left to do is plug in well, we should test it first. We'll test our solder joints first and make sure that we aren't shorted to ground anywhere. And then we'll fire it up and make sure that this thing works.